Another day, another story. A digital twin is a virtual representation of a real-world object, system, or process. It combines physical and digital elements to create a dynamic, real-time model that can be used for analysis, monitoring, and simulation. Welcome to Tabo Eminent Channel. The concept of digital twins has gained significant traction in various industries, including manufacturing, healthcare, transportation, and energy. Digital twins are created by collecting and integrating data from various sources, including sensors, IoT devices, and historical records. This data is used to build a virtual model that mirrors the physical counterpart, capturing its characteristics, behavior, and interactions. The digital twin then continuously receives real-time data, allowing it to reflect the current state of the physical object or system. The primary purpose of digital twins is to enable better decision-making, optimization, and predictive analysis. By simulating scenarios and analyzing the digital twin's performance, businesses can gain insights into the behavior of their physical assets and systems. This information can be used to improve efficiency, identify potential issues, and optimize processes. Digital twins have numerous applications across different sectors. In manufacturing, they can be used to monitor equipment performance, predict maintenance needs, and optimize production schedules. In healthcare, digital twins of patients can aid in personalized medicine and treatment planning. In urban planning, digital twins can simulate and analyze the impact of infrastructure changes and optimize resource allocation. Twin types. Digital twins can be classified into three main types: product twins, process twins, and system twins. Product twins focus on individual physical assets or products. Process twins represent a specific manufacturing or operational process. And system twins encompass larger-scale systems like smart cities or interconnected supply chains. Benefits and advantages. Explore the benefits that digital twins offer. These include improved operational efficiency, reduced downtime, optimized maintenance schedules, enhanced product quality, increased safety, cost savings, and the ability to predict and prevent failures. Use cases. Provide specific examples of digital twin applications in different industries. For manufacturing, digital twins can enable predictive maintenance, simulate production scenarios, and optimize supply chain logistics. In healthcare, they can support remote patient monitoring, aid in surgical planning, and facilitate drug discovery and personalized treatment. Explore other industries such as energy, transportation, construction, and agriculture. Integration with IoT and sensor networks. Discuss how digital twins rely on data from IoT devices and sensor networks to capture real-time information about the physical object or system. Explain the importance of data collection, connectivity, and interoperability to create an accurate and up-to-date digital representation. Data analytics and AI. Highlight the role of data analytics and AI in digital twins. These technologies analyze the data collected from the physical twin to generate insights, detect patterns, and enable predictive capabilities. AI algorithms can optimize processes, simulate scenarios, and make recommendations for improved performance. Challenges and considerations. Address the challenges and considerations associated with digital twins. These include data privacy and security concerns, the need for standardized data formats, and interoperability. The complexity of integrating multiple digital twins into a larger ecosystem, and the requirement for skilled professionals who can develop and manage digital twin systems. Future developments. Discuss the future prospects of digital twins, such as advancements in virtual reality and augmented reality technologies. An increased use of digital twins in smart cities and infrastructure planning, and the potential for collaborative digital twins that connect multiple stakeholders across an ecosystem. Furthermore, digital twins play a crucial role in the development and testing of new products and services. By creating a digital twin early in the design phase, engineers and designers can simulate different scenarios, iterate on designs, and optimize performance before investing in physical prototypes. As technology advances, digital twins are becoming more sophisticated and integrated with other emerging technologies like artificial intelligence, machine learning, and big data analytics. These advancements enable more accurate modeling, real-time monitoring, and complex simulations. In summary, digital twins offer a powerful tool for understanding, optimizing, and predicting the behavior of physical objects, systems, and processes. By leveraging the virtual model and real-time data, businesses and industries can make informed decisions, improve efficiency, and drive innovation. Thanks for watching. Request you to subscribe the channel.